And also, just before I forget, tomorrow, I will make a note of this at the end of the lecture again as well. But tomorrow I'm going to be gone for some appointments, so there will not be math class tomorrow morning. So after today, I won't see you guys again until Thursday. So today we're going to be looking at micrometers. There are actually a couple of different styles of micrometers. What most micrometers look like is almost like a large C-clamp. Something like this. You have one precision surface on this end. Then on this side, you have a precision surface that moves in and out as you screw on the thimble. So this part here is the part that actually moves. This is referred to as the barrel. It stays stationary. It is attached to the whole big C-looking, clamp-looking part of the micrometer. This part here turns, it rotates. And as it turns, it slides in and out. So if you loosen it all the way up, it moves all the way out. If you tighten it down, it goes all the way in. One turn of that thimble, that's called the thimble, by the way, moves it 1/40th of an inch. So it's very, very precision threaded. Because of that, the 40th of an inch, you literally have to do 40 turns to go from 0 inches out to 1 inch. Well, if it were 2 or 3 inches, that would take an extremely long time to turn it out there. So most micrometers have only 1 inch of travel. So standard micrometers are what we call 0 to 1 inch micrometers. They measure anything from 0 inches in size up to 1 inch in size. If we need to measure something larger than an inch, we do have 1 to 2 inch micrometers and 2 to 3 inch. The largest I've ever seen is I had a student who actually brought one in a few years ago that was a 7 to 8 inch micrometer. I had never seen one that big before. I had never seen one over a 4 inch micrometer personally before that. But they do make them larger, so like the 2 to 3 inch, what that means is if I look at those jaws, it won't tighten down all the way. If it's all the way in, there's a 2 inch gap. If we loosen it all the way out, it'll go out to 3 inches. So that's what the 2 to 3 inch micrometer means, is the smallest it will go is 2 inches. This surface will never touch this other surface. So let's take a look at how we read these. So again, this is the barrel. And this over here is what we had called the thimble. On the barrel, the numbers are tenths of an inch. So this is 0.1 inch, this is 0.2 inches. Well, we read that main scale on the barrel at the edge of the thimble. So this is 0.2 inches, but there's that extra mark there. We notice there's 4 marks in between the 0.1 and the 0.2. Those are what we call quarter marks. When we looked briefly on Thursday at the vernier caliper, we saw those quarter marks as well. Each of those is 25 thousandths. So this would be 0.1. That would be 0.125. That would be 0.150. That would be 0.175. And so on. Well, this one is 0.2, 0.225. So that is the main scale. Then we read the thimble. The thimble is read at the axis of the main scale. So we can see what lines up with that axis right now is the 15. That is thousandths of an inch. So we've got 0.225 plus 15 thousandths is 0.240 inches. So 240 thousandths of an inch. So for this one, that would be 0.4. Question is, have we passed that quarter mark there? Well, if we look at the thimble, we're right at 0 there, which means we haven't passed it. We are exactly on that quarter mark. That's 0.425 plus 0 on the thimble, so just 0.425 inches. So the same type of thing here. This is 0.7, this is 0.775. Have we made it to the 8 or not? Well, again, we look at the thimble. We're exactly on a 0, which means we've just touched. We're exactly on the next line on the main scale. So we are exactly on the 0.8. So that's exactly 0.800 inches. Now, looking at our discussion from a couple weeks ago, do we need those zeros there? Could we just say 0.8 inches? Well, mathematically, 0.8 and 0.800 are the same numbers, but from the measurements point of view, we need those zeros to tell us that we did actually measure to the thousandth of an inch. So for this one, let's get something a little bit more interesting. So this will be 0.9, 25, 50, 75, so 0.975. On the thimble, it's the 5 that lines up, so that's 5 thousandths. We add those up, that is 0.980 inches. This one, as we look at it, have we made it to the 6? Well, if we look here, this is at 24. We are not quite back to the 0 yet. So no, we have not quite made it to the 6 yet. So this is 0.5, 25, 50, 75, so 0.575. Well, we've already read the thimble, that's 24, so we're going to add another 24 thousandths to that. So 0.599 inches. Makes sense. We said we were just short of making it to the 6. 0.599 is just short of the 0.6. I'm going to have you read this one in your notes. We'll go over it in about 30 seconds. So this is 0.625. We have passed a quarter mark. And this is 1, so 0.001 off the thimble. So that's 0.626 inches. we'll have you read, excuse me, have you read this one in your notes. We'll go over it in about 30 seconds. So this is 0.3 and then 25, so 0.325. On the thimble, this would be 13. Another 13 thousandths, so that is 0.338 inches. Now, unlike the caliper, where we had 4 different measurements, if you recall from last week, built into the caliper, it was able to do the outside measurement, inside measurements, the step up, and the depth gauge. Micrometers, standard micrometers, are only capable of this outside measurement because of the way they're built. But we do have inside micrometers that look like this. First of all, you'll notice this piece right here, that is an extender. That is a 3 to 4 inch extender. What that is saying is whatever measurement we are starting here starts with 3 inches. And then over here, this is 0.225, so 3.225. Then we read the thimble is a 20, so that's 20 thousandths. So that'll be 3.245 inches. So I want you to look very closely at this one and then compare it to this one. Both of them have the 3 to 4 inch extender. But you'll notice something extra on this one that this one does not have. This extra little piece right here. That is a 1/2 inch extender. What that means is that this one is starting not at 3 inches, but 3.5 inches. Then we read the barrel. This is 0.325. Then we read the thimble. That's going to be 12. So that is 3.837 inches. So this one here has a 2 to 3 inch extender, which means we're starting out at 2 inches. This is 0.32550, so 0.350. Now we have to be careful here. This is 20, 21, 22, 23, 24 on the thimble. So 2.374 inches. Here again, we have a 3 to 4 inch extender, so we're starting out at 3 inches. We have the 1/2 inch extension, so we're starting out actually at 3.5 inches. On our barrel, this is 0.125. And on the thimble, we're at 10. That's 3.635 inches. I'm going to have you read this one in your notes. We'll go over it in about 30 seconds. So this is 4.5. This is 0.4, 25, 50, 75. And on the thimble, that's a 24. So that's 4.999 inches. Well, next we'll switch over to metric. We know this is metric because for two things. One is our main scale is no longer numbered in ones, it's numbered in fives. And our thimble no longer goes 0 to 20 and then back 25 is back to 0. It goes 0 to 45 and then 50 is back at 0. Now on the main scale here, we see that there are little lines in between the main lines. So this is, 15, 16, 17, 18, 19, 20. These are halves. This is 15, 15 and a half, 16, 16 and a half, 17, 17 and a half, and so on. So this one here, this is 20. Have we made it past the 21? Well, we look at the thimble, and here's 0. We have just passed 0. We are on 5. So we have made it past 21. Now, the main scale on a metric micrometer is in front of the decimal point. So that is 21. The thimble is hundredths of a millimeter. So that 5 is technically 0.05. So we have to be careful to make sure that the everything goes in the right decimal place. So just like with our calipers, the difficulty going back and forth between, going back and forth between metric and standard is going to be locating the decimal point. So this one here, 15, 16, 17, 18 and a half. Now we might say, have we made it past that because we're not back to 0? Well, we can clearly see space on the other side of the line. So yes, we have made it past that. What it's saying is we're almost to the next line. So that is 18.5. And this is 45, so 0.45. That's 18.95 millimeters. Here we have 5, 6, 7, 8 and a half. Now we're right on 0 here, which means we've actually just made it to the next line, which means even though we don't really see, we barely see the edge of that line, we are right on 9. That is 9.00 millimeters. This one here, so 10, 11, 12, 13. Have we made it to the 14? Well, yes, we've just passed 0. That means we did pass the 14. This is 1, 2, 3, so that's 14.03 millimeters. We got to remember that thimble is hundredths of a millimeter. Let's jump back and forth a little bit. This one's back to be an inch. We know it's an inch because this is numbered in ones. We can't see what the thimble where it rolls back to 0. But we would know it goes up to 20, and then 25 would be back to 0. So this is 0.4, because this is inches, 25. And this is 9 hundredths. This is 0.434 inches. This one here, 0.725. Then this is going to be 22 thousandths of an inch. So 0.747 inches. Here we're jumping back to metric. So on our main scale, this is 15, 16, 17 and a half. We have not quite made it to the next line, so it's just 17 and a half. This is 35, so 0.35. So that's 17.85 millimeters. And finally, this last standard one. Again, we know it's standard because we're numbered in ones here. And this hits 20, and 25 goes back to 0. So this is 0.8, 25, 50, 75. We see the 9, but we're not quite back to 0 yet here, which means we've not quite made it to the 9. This is a 23, so that's another 23 thousandths. So 0.898 inches. Well, like I said, just like with the caliper last week, the trick is keeping the decimals in the correct spot. Now, there is such a thing as a vernier micrometer. What the vernier micrometer looks like, I don't think I have that applet downloaded on here. I do not. What the vernier micrometer looks like is it has the on the main scale on that barrel, you have the main set of numbers here. Like that. Then up above it, there are lines that are numbered 1, 2, 3, 1 through 9, basically. And those are the vernier scale. What that does, let's finish filling this out here. Not my best artwork, but you kind of get the picture. So here we read the main scale, 0.5, 25, 50, 75. Here we're between the 11 and the 12. We're closer to the 12, but we have a vernier scale. So we're going to read the 11. The vernier scale here tells us that's what lines up is that line there. That's the 4. That's actually 11.4 is what the thimble is reading. So all the vernier scale does is adds this extra digit on the end of our measurement. And we just see which one lines up here with the thimble. So that measurement is 0.5864 inches. Now, most of what you guys are going to do will not require the precision of going to that 10,000th of an inch. A vernier micrometer really is only going to be in precision machining and CNC. Okay, so homework. Back out of the textbook here. Page 183. I'm going to have you do all of 1 through 20 just because they're quick reads. And page 186. Also 1 through 20. And remember, tomorrow I will not be here. So November 4th. No math class. Okay, that's all we have for new material today. So I'm going to shut down the recording, and if you guys want to get started on that, I'll be here